Hey everyone, this is Andy Malbuff, and we're going to continue looking at checking for student correctness when they input information in Desmos Activity Builder. Now, previously, in previous videos, we've looked at how to check for multiple choice correctness and check boxes, which are pretty easy. Desmos does that automatically for you. And we've also learned how to use computation layer to check for numeric input to see if it's correct, and also to check the table input to see if it's correct. And now we're going to extend that to graphing components and how we can use those components to check for correct student input. Now, to begin with, on this screen, this is one that I like to use a lot, this concept where we ask students to match a graph. And so I provide them with a linear equation and ask them to match it. And this one has a slope of 3 and a y-intercept of -2. And I've set this up also so that there's a timer involved using some of my interpretive feedback stuff from earlier. So the student, when graphing this, gets immediate feedback that they are correct, but the teacher dashboard doesn't tell me anything. So this is really important for teachers that are working remotely and they're viewing the dashboard to see an entire classroom worth of students, and they want to know quickly and easily if this is correct or incorrect. And right now this dot means Desmos can't grade it correct or incorrect. So how do we do that? Well, we're going to go into editing here, and we'll take a look at how this is set up. In the graph component itself, here's what I want students to see initially, and I used a dash line for that. And I want g of x to be what their input is going to be. I want to see the student's result graph there. Desmos doesn't know how to graph this yet because it doesn't know what g is and doesn't know what t are. And those two items are going to be defined in the computation layer. So before I go further, let me just review quickly how we do that. We define function g in this manner. Let me make this a little bit easier to see. We're going to define function g as being a simple function, and it's going to use input2 as its component, and it's going to search for the LaTeX that the student types in for input2, and that's going to define g. Also at the same time, we're going to set the number t, or define the number t, also based on input number 2, but this time its source is time since submit. So it's going to start a timer once the submit button is pressed, and it's going to count for 10 seconds. So we're using input 2 in two different ways here. Also here, I don't want Activity Builder to grade this particular graph as being correct or incorrect. I just want it to be read. So we enable that with read only true. So let's go back here to our editing and let's jump back into the graph. And again, I do need to make this bigger. So what we're going to do here that's new is in box number 3 here, I put a little note. We're going to create a list of values to evaluate in those two functions, f and g. And we're going to make that list be defined as, and I use capital X for a list, the numbers from -3 to 3. And I put 3 little dots in between, and that creates a 7-element list. And what we're going to do then, down below, is we're going to determine the difference of those two functions, f and g, at each input when put in above. And if the student matches the graph correctly, the difference in the two functions should be 0. So here's how this algorithm works down here. I'm going to do a little highlighting. We're going to take the difference of g of x minus f of x. Notice those are capital X's, so those are using our list values. And it doesn't matter which one we have first because we're using absolute value to find the difference. And so that'll always be a positive number. And ideally, if the student inputs a correct equation, the total of those differences will be 0. That's what this part indicates. And if the total is 0, it's going to assign the value of c to be 1. And I use c for correctness. So if the total of all those differences is 0, c is going to be 1. If it's not, c will be 0. Well, then I have to tie that over here to my input. So I'm going to go into the computation layer. I'm going to use the correct sync. and I want to use graph number 2, which is where we're just at as my component. I want the number from graph 2, capital C, I use for correct, and I want that to be 1. So if graph number 2's number C is 1, decimals will grade this as correct. Let's preview. As soon as the student types in y equals 3x minus 2, the teacher dashboard shows a check, and then the rest of the graph interaction occurs as designed. So that's one way that we can use a graph component to check for correctness. Now, if you're interested in adding a few bells and whistles and maybe spicing this up from the student perspective a little bit, I can show you a different way, or not a different way, but an extension of what we just looked at. Here's a screen asking students to graph an equation. This time, instead of providing them with the equation itself, I give them 2 points here, okay? And obviously, we want a line to go. No, I guess we wouldn't have to have a line, but it's designed for a line. So I'm going to type in y equals 2x plus 2. And that's not plus 2. And as soon as that's typed in, there's a correct check right here. When the student hits submit, here's the extra spice to this, okay? They'll see the line being graphed, and they get a little piece of visual feedback right next to each point that the line went through. So how do we make that happen? Well, let's jump into the computation layer. And I first want to show you the graph component and what I have set up to graph here. First of all, here's f of x, but it's not defined as anything. I'm going to dump these 2 sliders for a moment so that you can see what it looked like in the previous screen there, where we don't have anything defined. I'm going to define f in the computation layer, and I'm also going to define t in the computation layer. Let's see again quickly how that looks. Here's f, same as previously. Here's t, same as previously. And so that's going to set or define function f along with the number t. Now in this component, I had added the sliders so that you could see below what's going to follow that. So sliding down just a little bit here, here are the 2 points that I want students to see, and I've used open circles, as you can see there. Then we're going to set 2 correct checks here, similar to what we did before, except I don't have to use the difference of functions. I just want to decide, does the point go through one of those 2 open circles? Or does the line go through one of those 2 open circles? So we're going to set C sub 1. This is our first correct check. We want to know if our function at -3 is equal to -4. Okay, so in other words, we want to see if our line goes through this point. If it does equal -4, we're going to assign C sub 1 a value of 1. If it doesn't go through -3, -4, it's going to assign C sub 1 a value of 0. So right now, C sub 1 is set at 0 because we haven't had our line go through this point right here yet. In a similar way, we're going to do a second correct check. We'll call it C sub 2. And this time I want to know if it goes through the second ordered pair. So we're going to say, is f of 1 equal to 4? If it is, we're going to assign C sub 2 a value of 1. If it's not equal to 4, we're going to assign it a value of 0. So right now it's set to 0. So third line down here, we're going to let our overall correct check, capital C, be the product of those 2. Because if both C sub 1 and C sub 2 are both 1, when I multiply them together, this will be 1. And down at the bottom, the last 2 spicy pieces to this. We're also going to graph -3, -4 again, only on a certain condition. It's only going to get graphed if C sub 1 equals 1, and when our line gets to that point based on the timer, then it's going to go through there. And we're going to do the same thing with 1, 4, our other point. We're going to fill it in as solid only if C sub 2 equals 1, based on this information right here. Now, I'm going to change this to be consistent with what I did earlier. The coefficients 4 and 5 relate to the speed at which the line is going to come through. I start them both back 10, similar to what I did up here at the top. And we're going to start this at -3, which is the x coordinate here. We're going to start the second one at +1, which is this x coordinate. And besides filling in those points when the line goes through, we're also going to have a label show up, and I just did a little emoji copy and paste for a check mark. So again, let's view that. I shouldn't say view that yet. I need to go into this one here. In the math input, we set our correct sync to be based on graph number 3's number C being 1. And that's a capital C, and that's the product of C sub 1 and C sub 2. So let's preview again, and I'll type in the correct response. Y equals 2x plus 2. C sub 1 and C sub 2 are both 1, so therefore capital C is a 1, and therefore we get the teacher dashboard check. Submit. Here's the first check, here's the second check. Now, you're probably wondering, what if the student hits one of the points? For example, what if they type in y equals 4x? This will hit one of the points. You'll see your line coming in. It hits the point in the first quadrant here, and we get the little check mark, but it doesn't hit this one, no check mark. And the teacher dashboard shows an X. That's because C sub 1 is 0, C sub 2 is 1, and the product of those is 0. So Activity Builder judges this as incorrect. So that's a little fancier way to inject a little flair into your student graphs for the student perspective.